In this video, I'll describe projectile motion, which is a special case of two-dimensional motion. It's two-dimensional motion when an object is in free fall. So here we have a classic example of a cannon. So the cannon fires some cannonball with an initial velocity v naught. So v sub 0, at time 0 the ball just leaves the cannon here. So it leaves here with an initial speed v naught at some angle theta naught above the horizontal. So it has an x component of initial velocity and a y component of initial velocity. Neglecting air resistance, as the ball flies through the air, the path that it follows changes. Its horizontal speed does not change. So the velocity in the horizontal direction, this Vx, you can see here it's Vx naught, Vx at time 0. It's kept this same notation here, Vx naught. That's because Vx at this time is the same as this one. And it's the same all the way down from the time it leaves the cannon until the time it reaches this point is the same height that it was originally launched from. That entire time the horizontal velocity is unchanged. What's changing is the vertical velocity. It starts with a large vertical velocity. Then as it comes here, you can see Vy is smaller. Here at the top, Vy is actually 0. So that's at the top of the flight. It's going up, so its velocity is in the up direction. It slows down, it stops going up, and then it turns and comes back down. So this velocity at the peak in the y direction is 0. And then the y direction velocity is going downward. And when it gets down to the same height that it was originally launched at, the velocity in the y direction is minus the initial y velocity. So this is called projectile motion, or sometimes it's called ballistic motion. It's when something's moving in 2 dimensions in free fall.